Hello, geometry students. I hope your day is going well. This is going to be a short little Vodcast of the review for Unit 9. As you know, we have been doing this for the whole entire year for each unit, and you can use these as a quick little review of the material in the unit. You can also use it and replay it at the end of the semester to help you remember everything you need to know for the final exam. As we go through the slides, please make sure that you are taking notes and writing down anything you don't remember or things that you need to study before the test or before the final. Hopefully you're ready, and here we go. So I hope you remember that chapter 9 is all about area. So area of all the different shapes with all of their formulas is the basic quick little review we're going to get today. So here is our first shape. This one should be familiar to you. I hope you remember this formula from previous classes. We know that the area of a rectangle is base times height. You can also use length times width if you prefer that one. The next shape is a parallelogram, and its formula should also look familiar to you. It is the same as a rectangle. Area equals base times height. The only difference is that the height of the parallelogram, as you see over here, can be outside of the shape. So sometimes it doesn't appear to be in the spot where you would think the height would be. Our next shape is a rhombus. A rhombus is really a special parallelogram, so technically if you have the height of the rhombus, you could use the parallelogram formula. Otherwise, we use this one, which is area equals 1/2 times diagonal 1 times diagonal 2. Quite often you'll use Pythagorean theorem to help you find the lengths of the diagonals. All right, moving on. Our next shape is a kite. And a kite actually looks very similar to a rhombus, and it does use the same formula. Area equals 1/2 diagonal 1 times diagonal 2. Let's remember always that you could treat pretty much all of these shapes as composite figures where you're finding maybe the area of one triangle plus the area of another triangle, if you see it that way, if that helps you. Our next shape, speaking of composite shapes, is a trapezoid. And a trapezoid really could be broken into two triangles and a rectangle. But instead, I'm going to remind you of the formula for just a trapezoid. And of course, if you remember, it's a little bit faster. So this is area is equal to the height times base 1 plus base 2, all divided by 2. Our next shape is a regular polygon. And remember, a regular polygon is any shape that has all sides equal and all angles equal. So like the hexagon or this octagon. We have a special formula for this, which is 1/2 perimeter times apothem. If you have forgotten what the word apothem means, you might need to look that up. But of course, remember, you could always break this into triangles and find the area of, in this case of the hexagon, 6 triangles, if you don't remember what the apothem is. Okay, next we have the area of a triangle, which I know that you remember the first formula, area equals 1/2 base times height. The second one is a little more specific. Area equals 1/2 AB sine of C, where A and B are two sides, and the C, the angle, is the angle in between the two sides. Next, we have area of a circle. Super easy. I know you remember this one from previous classes. Area equals pi r squared. Don't forget, oh, I have to put the pi after the r squared. Next, we have the area of a sector. A sector is a chunk of the circle. Sometimes we talk about it being a piece of pizza. And the formula for this is area equals n over 360 times pi r squared. The pi r squared is the area of the circle, and the n is the angle measure in the corner of the sector. So if this is 100, then 100 goes in the spot with the n right there. Finally, here we have the area of a segment. And a segment, I always talk about it being a piece of the pizza crust, where you're going to only be looking at this little piece on the outside of the circle. And this is really just taking the area of a sector, so this is the area of a sector right here, and subtracting the area of the triangle that is on the inside, and that will give you that little hope that was helpful for you. Make sure if you have any questions, you go back and review or ask me when